We've got Professor Lewin releasing a ball attached to a pendulum. It's going to swing back and forth, and the initial height he releases it from starts at 1.8 meters above the lowest point in the problem, so above the lowest point of the swing. So this initial height right here is 1.8 meters. And we're trying to figure out how fast the ball will be when it's in its lowest point in the problem. So again, we've got a conservation of energy question where all of the energy initially has to add up to all of the energy at the final location, in this case the final location being at the bottom of the swing. And at the top, because he's gripping the ball, there is no velocity, it is only potential energy that it starts with. And at the bottom, assuming there's no losses or anything like that, it all gets converted to speed, which is energy of motion. So it all gets converted to kinetic energy. So once again, I get my mgh initial is 1/2 mv final squared. The masses cancel. And if I solve it for v final, it becomes root 2gh. Multiply both sides by 2 to get rid of the 1/2 and then take a square root. So I get the square root of 2 times 9.8 meters per second squared times 1.8 meters, which gives me 5.9 meters per second at the bottom of the swing. Now that's all question A. The rest of these questions are conceptual, so let's have a look. How high would the ball go on the other side? So if there's no energy lost at all to heat or sound or anything, if there's no losses, all we're dealing with is kinetic and potential. By the time that ball reaches the other side, it will just keep its pendulum motion and end up exactly symmetrically 1.8 meters above on this side. All that kinetic energy at the bottom would be all converted back into potential energy, and your total amount of energy must remain constant. So whatever energy I started with, which was all potential, must be held true at any point in the path. So it makes sense that his final height on the other side would also be 1.8 meters. Now, since there is actually a tiny little bit of energy lost, what do we expect about the actual height at any location, A, and at the far side, we'll call that location C? Well, because you're losing a little bit of energy, at any location, instead of maintaining your original potential energy, you're going to always be leaking a little bit away to heat and sound and whatever other energies are present. So it's never going to rise quite as high as it started. So it's always going to be a little bit less than 1.8 meters as it swings back and forth. It'll continue to get lower and lower and lower as energy is continuously released to the environment in the form of heat. Question D. So how can he be so confident that he won't go to the hospital? Well, simply because it's a closed system. There's nobody running out, adding any additional energy. So as long as he knows what his initial energy is, which is all potential, 1.8 meters off the floor, it'll never gain more energy than he started with. So it can't go past 1.8 meters. However, you did notice in the video that he was awfully careful as to how he released the ball, and that's because he didn't want to add energy. No energy should be added. And by that I mean he doesn't want to give the ball a slight push, because if he does, then it also has an initial kinetic energy. So now we have no idea what the final height would be because we have this unknown initial energy that we have to add to the system. So he doesn't want to give it a push.